This question says, evaluate the function f of x equals x squared plus 3x minus 8 at the given values of the independent variable and simplify. So our independent variable is 4. That 4 gets substituted in for x, and we're finding the y value, f of 4. So our function is f of x equals x squared plus 3x minus 8. If I want to find f of 4, see 4 is going in place of x. Everywhere I see an x, I change it to a 4. So that's 4 squared plus 3 times 4 minus 8. And I want to simplify following order of operations. 4 squared is 16. 3 times 4 is 12. 16 plus 12 would be 28. Minus 8 would give me 20. I'm going to do the same thing with the next one. So the next one is f of x plus 2. Everywhere I see an x, I change it to x plus 2, so that would give me x plus 2 squared plus 3 times x plus 2 minus 8. I'm going to work out x plus 2 squared to be x plus 2 times x plus 2. We can use the distributive property, distributing the 3. That's 3x plus 6, and carry down that minus 8. Then let's multiply out x plus 2 times x plus 2. That's x squared plus 2x plus 2x plus 4. Carry down that 3x, and I can go ahead and combine the 6 and the negative 8 to be negative 2. I'll combine like terms. Carry down the x squared. I've got 2x, and 2x is 4x. Another 3x, that would be 7x. And then the 4 minus 2 would give me a plus 2. So that's f of x plus 2 is x squared plus 7x plus 2. So you notice that when we substituted in a number to the function, we got a number as the answer. But when we substituted an expression with x, our answer still had an x in it. So the same thing's going to happen with our next one, which is f of negative x. Everywhere we see an x, we change that to a negative x. That's negative x squared plus 3 times negative x minus 8. Negative x squared is negative x times negative x. We have a positive times a negative, which will be a negative 3x. Carry down that minus 8. Negative times negative will be a positive, and x times x is x squared. Carry down that 3x, carry down that minus 8, and that's our answer. F of negative x is equal to x squared minus 3x minus 8. For this question, a graph of a function is shown to the right. Using that graph, find the following function values. That is, given the inputs, find the outputs. We have f of negative 14, f of 0, and f of negative 7. And the graph shown on the right is a linear graph. So what we need to pay attention to here is understanding the notation that we see. We have this notation, which is our function notation, f of negative 14, and the meaning of this notation is the value that we have inside the parentheses is our x value, and the output is the y value. So because we've been provided a graph with ordered pairs, there's no calculation needed. We would just read the graph, looking for an x value of 14, and then we can record what the y value is at that point. So I'm going to look over here on my graph, and I'm looking for an x value of negative 14, which would be here. we want to get onto the graph. This point right here is on the graph and it has an x-coordinate of -14. And we can look over here to the y scale and record what that y-coordinate is. So we know the ordered pair -14, 5 is on this graph. And that means that f of -14 is 5, the y-coordinate at that x value of -14. We can do the same thing with the next one, f of 0. So 0 is the x, and x of 0 would be right here. We want to go to the graph and record what that y-coordinate is. So that ordered pair has an x-coordinate of 0 and a y-coordinate of -5. So we have f of 0 equaling -5. The last one we have here is f of -7. -7 is our x. We want to find an ordered pair on the graph with an x-coordinate of -7. And that would be right here. That ordered pair is on the line. It has an x-coordinate of -7. We can see that it has a y-coordinate of 0. So f of -7 is 0. The next question says, classify the given function as a polynomial function, a rational function, or a root function. Then find the domain. Write the domain in interval notation. So our function is f of x equals 4x cubed minus 3x. So we want to decide whether this function is a root function, a rational function, or a polynomial function. So let's go through each category just briefly. A root function, or sometimes called a radical function, will have a radical in the equation. So it'll have like a square root or a cube root. A rational function is a function where you would have a fraction, and that fraction would have a variable in the denominator. And then finally, a polynomial function. Polynomial functions don't have radicals or fractions. Well, they might have a fraction in the coefficient, but you wouldn't have a variable in the denominator. And the powers on the variables are going to be whole number powers. So for this example, looking at it, I don't see any radicals and I don't see any fractions. So I'm looking at the powers on x, and I've got a power of 3 on this one and a power of 1 on this one, and those are both whole numbers. So I would classify this as a polynomial. And then once we decide that it's a polynomial function, we want to answer the second part, which is what is the domain of this function? So all polynomials will have a domain of all real numbers. So we don't really need to do any calculation on this one. It's more of a memorization thing. Once you know you have a polynomial function, you know that any value of x can be substituted in, and we write that the domain is from -infinity to infinity. That is saying that all values of x can be substituted into this function from -infinity to infinity. Okay, on this one, it says classify the given function as polynomial, rational, or root, and then find the domain. So we've already got it marked as rational, and it is rational because it's got a variable in the denominator. To find the domain, we're going to take the denominator and we're going to set it equal to 0. Now the reason why we're setting it equal to 0 is because having a 0 in the denominator is undefined. And that would mean that if it's undefined, then it can't be in the domain. So we're going to take whatever expression is in the denominator, we're going to set it equal to 0 and solve that equation to figure out what values we need to exclude from the domain, because those values cause the domain to equal 0. So with this one, it's a polynomial function that I'm solving here. Just to be clear, this equation, or sorry, this expression is rational, but this equation is polynomial. Just the denominator's polynomial. And I'm going to solve this by factoring. I can factor out the t, and then that gives me t squared minus 6t minus 7. I can factor this quadratic a little bit more. T and t, 7 and 1, with a minus on the 7 and the plus on the 1. And then you can set each factor equal to 0. So t equals 0, t minus 7 equals 0, t plus 1 equals 0. T equals 0 is already solved. We've got t equals 7, t equals negative 1. And these are the values that I'm going to exclude from the domain. So I'm going to draw a number line. And I want to exclude a negative 1, a 0, and a 7. But I'm going to include everything else on the number line, so I'm shading everything else. Each one of these sections need to be written in interval notation. So the first section has a lower bound that would start at negative infinity and would stop when we get to that open circle that I've drawn, that value that we're going to exclude. Then the next one is going to start at negative 1 to 0. The next one goes from 0 to 7. And the last one goes from 7 to infinity. So this is going to be our domain. Our domain is every real number except for negative 1, 0, and 7. And this is how we write that in interval notation. This question says, classify the given function as a polynomial function, rational function, root function, and then find its domain. Write the domain in interval notation. So for this function, we have h of t equals the cube root of negative 2t to the fourth plus 9. And we would categorize this as a root function because it has a variable underneath the radical. Now with root functions, it breaks out into two more categories, and you want to have these categories being even root and odd root. And what that's mentioning, or what that's pertaining to, is the index on the radical. So the index on this radical is a 3, so that makes this example an odd root. Now the thing that's interesting about odd roots is that there are no restrictions, meaning that you can take the odd root of a positive number and get a real number. You can take the odd root of 0, and that's 0, which is a real number, and you can take the odd root of a negative, and that's a real number. So we have no restrictions on odd root functions. So when we have no restrictions, that means that we have no restrictions on the domain, and your domain will be all real numbers, which is negative infinity to infinity. So the domain of h of t equals cube root of negative 2t to the fourth plus 9 is negative infinity to infinity. We want to classify the given function as a polynomial function, a rational function, or a root function, and then find its domain. Write the domain in interval notation. The function we're working with is g of x equals the 8th root of 9 minus x. So I don't know if that makes the classification of the function obvious, but we have the 8th root, and that's going to make this a root function. Now, more specifically, we want to pay attention to the index of the root, because the index classifies it even further, and we find the domain differently when we have an even index versus an odd index. So 8 is an even number, and so we have a root function with an even index. A root function is a function of this form, the nth root of some expression g of x, and we are doing an even root. And what we want to pay attention to is that when we take an even root of a negative number, that's going to result in a complex or imaginary number. Right now, we're only interested in real function values, and so we are not going to consider these imaginary or complex numbers. So that means that we need to restrict what is allowed inside of our radical or underneath the radical. We want only non-negative values, 0 or positive. So when we're trying to find the domain, we're going to create an inequality where the expression underneath the radical is greater than or equal to 0. And when we solve that inequality, it will lead us to the domain. So for our function, g of x equals the 8th root of 9 minus x. 9 minus x is the expression underneath the radical. And we're going to create that inequality. 9 minus x is greater than or equal to 0, and solve. So we're going to subtract 9. That gives negative x is greater than or equal to negative 9. Divide by negative 1 on both sides. We're dividing by a negative, which means we need to reverse the inequality symbol. And that gives x is less than or equal to 9. On the number line, we would mark 9 with a closed circle, a filled-in circle, because we're going to include 9 in this set, and we want to shade all the values that are less than 9. So if we want to write that in our interval notation, that will be negative infinity to 9 with a bracket on the 9. So that bracket has the same meaning as the filled-in circle. So we have negative infinity to 9, including 9 as the domain of this root function with an even index. Thank you for checking out my videos. Have a great day.